Hi, welcome to this video. This is 9-4, and we're going to solve exponential equations algebraically, building upon our knowledge of exponents, which we talked about yesterday. Here is our prior knowledge. Go ahead, please take a second, pause this video, and just think about how you would do this. How do you write each of these rational numbers as a power of 4? All right, here are the solutions. 16, that's 4 squared. 1 over 64. Well, 64 is 4 cubed. So in order to make it as base 4, we have to add in the negative exponent. And then anything to the power of 0 is 1. So 4 to the power of 0. Okay, as promised in the last lesson, today we're going to learn the exponential property of equality. It's not necessarily important that you know exactly what it's called, but you do need to know how it works. So the exponential property of equality can be used in order to solve exponential equations, specifically where both sides can be written as the same base. And this is what the exponential property of equality says. It says if b to the power of m is equal to b to the power of n, again, where b is our base and then m and n are just either a variable or a value, then m must be equal to n. And that makes sense. If the left is equal to the right and the bases are the same, well, then the exponents have to be the same. That's the exponential property of equality. Here are the steps that we're going to use in order to solve using the exponential property of equality. Step number 1, write the equation with a single term on each side. So if you have multiple terms, we got to get rid of terms. We got to combine like terms. Step 2, write each term as a power using the same base. Sometimes you have to be creative here. Step 3, you use the exponential property of equality to set the exponents equal. Once you have each base equal, you just set the exponents equal to each other. And then number 4, you're going to go ahead and solve that equation. Step number 5, state the solution to the equation. So x is equal to blah. Okay, so those are the steps. All right, so here's our first example. Please go ahead and write this example down. We have 4 to the power of x is equal to 16. Now, I want to go ahead and solve this. And if I can make them the same base, I can go ahead and use the exponential property of equality. So 16, I want to use base 4. Here, this equation is base 4. So I'm going to rewrite 16 as base 4. So I have 4 to the power of x is equal to 4 to the power of 2. So I can go ahead and I can use the exponential property of equality. The property of equality says if you have the same base, you have the same exponents. So here, x is equal to 2. Here's example number 2. Please go ahead and write this one down. Heck, quick. Do I need to go back, viewers? Four to the power x is equal to 4 squared. X is equal to 2. All right, example number 2. Please go ahead and write this one down. We have 5 to the power of x is equal to 1 over 125. Now, the goal of this, the first question that should pop into your head is, can you make these the same base? Do they have the same type of family? And hopefully you see 125 and you're like, yes, that is 5 to the power of 3. So I have the same base, but again, they both have to be base 5. So I'm just going to rewrite 1 over 5 cubed. I'm going to use the negative exponent property. I'm going to bring it up. And now I have them as the same base, okay? And if I have the same base, the property of equality says the exponents must be the same. Good. X is equal to negative 3. Good. We're going to make it harder here in a second. Here is a practice problem. Please pause the video. Go ahead and try this. All right, here is the solution. So I have 3 to the power x. You can rewrite both as base 3. So therefore, the exponents have to be the same. x is equal to 3. Here is round 2. Go ahead, pause the video, and try this one. Okay, so for this example, a little bit more tricky. We just have to rewrite 16 as base 2. So this is 2 to the 4th. And then because it's in the denominator, we have to use a negative exponent property. So 2 to the power of x is equal to 2 to the power of negative 4. So therefore, x is equal to negative 4. All right, let's go ahead and kind of dial up the heat a little bit. Just a little bit. Okay, so I have 36 to the power of x is equal to 6. So I need to write these as the same base, and not too complicated. Here I have 36. Well, that's 6 squared. And 6, that's 6 to the power of 1. So in this situation, this is power of a power. We did this earlier in the year, power of a power. You multiply those. So really this is 6 to the power of 2x, which is equal to 6 to the power of 1. So hey, I made the bases the same. They have the same base, therefore their exponents have to be the same. 2x is equal to 1. 2x is equal to 1. Now I have to go ahead and I have to solve this equation. So I'm going to go ahead and I'm going to divide both sides by 2 to isolate x. So we get x is equal to 1/2. And this should make sense too, because if I plug in 1/2 here, isn't 36 to the power of 1/2? That's the square root of 36. Is that 6? Yes. So sometimes you can think about it conceptually. All right, next example. Here they're getting tricky. Notice I have 1/7 to the power of x is equal to 49. I want to go ahead and I want to get the same base. Have to have the same base. So what base am I going to use? Yes, 7. Okay, so here I'm going to go ahead and say, okay, this is 7 to the negative first. And 49 is 7 to the power of 2. So using power to a power, I get 7 to the power of negative x is equal to 7 to the power of 2. And because I have the same base, the exponents have to be the same. So now negative x is equal to 2. And I'm going to go ahead, I'm going to divide each side by a negative 1. And we get x is equal to negative 2. All right, here is a practice problem. Please go ahead, pause the video, and we'll show the solution here in a second. All right, here is the base. You should have used base 4 for both of them. Now 64, that's base, or sorry, 4 to the power of 3, and 1/4, that is 4 to the power of negative 1. So again, if we go ahead and distribute that negative 1 to the x, we get x is equal to negative 3. Here is the next practice problem. Please go ahead, pause the video, and try this one. All right, so for this example, here we have to make the both base 2. So the 8 is going to be 2 to the power of 3. And 2 is just 2 to the first. I can put a 1 over here. I'll go ahead and multiply my two exponents. So I have 2 to the power of 3x is equal to 2 to the first. Exponential property of equality says if you have the same base, the exponents have to be the same. So 3x is equal to 1. And then I just have to go ahead and solve this simple linear equation. X is equal to 1/3. Awesome. Okay, let's go ahead and look at some fun ones. 4 to the power of x is equal to 32. 4 to the power of x is equal to 32. Now, the question in your head is, okay, I need to make them the same base. And we see 4, where we accept 4 into our life. I mean, it's my favorite number. I accept 4. And then you're like, 32. Okay, 4 to what power is 32? Not possible. It's not feasible. So what we have to do in this situation is we have to change both sides. 4 to the power of x. This is 2 squared. 32, that's 2 to the power of 5. Now, I chose those specific ways to rewrite the expression because both of those are base 2. I have to find the base that they can both be the same to use the exponential property of equality here. Okay, so I have 2 squared to the power of x. That's just 2 to the power of 2x. And 2 to the power of 5 stays the same. Okay, same base. Exponents must be the same. So 2x is equal to 5. I'll go ahead and divide by 2 on both sides. And we get x is equal to 5/2. If you don't like fractions, you can write 2.5. But either way is right. I got an email. That's what that means. Okay. Here is the next practice one. Please try this one. I'll show you the answer here in a second. All right, hopefully this one wasn't too bad for you. If you're performing like my students here in class, I mean, they are pretty special, but they did really well in this. And in special, I don't mean special. I mean highly intelligent on most days. There's some days. Woo! So, don't take me to court. They're good kids, I promise. 9 to the power of x, that's 3 squared. 27, that's 3 cubed. And I won't tell you Cynthia Lewis' name, so you don't even know who these kids are. Okay. 3 to the power of 2x is equal to 3 to the third. What's your middle name? You mean I can look up her address really quickly? Okay. That's true. All right, here we go. Okay, the last home stretch of these problems, and don't be freaked out by these. These really aren't that scary. Yeah, they look scary, but they're not. It's like your boyfriend and girlfriend, right? They look really ugly, but when you get to know them, they're not that bad. Okay, 2 to the power of 6x is equal to 8 to the power of x plus 1. Remember, can I write these as the same base? And the base that we're going for here is 2. So 2 to the power of 6x is equal to 8. This is 2 to the power of 3. And I'm going to put x plus 1 in parentheses there, because what we're going to do next is pretty important. Okay, now, do you guys agree I have the same base? Yes. So therefore, if the bases are the same, the exponents have to be the same. I put that parenthesis around the x plus 1 because if you do multiply this, you need to distribute. It's 3x plus 3, okay? So that those parentheses around that binomial, right? 2 terms, binomial, the x plus 1 is important. So now I want to go ahead and I want to solve this equation. So we're back to linear equations, which is not too bad. So I have 6x is equal to, and I'm going to go ahead, distribute first, right? This is 3x plus 3. I'm going to combine like terms. So what do I need to combine? Yeah, the x's. So I'll subtract 3x from this side, subtract 3x from this side. And we get 3x is equal to 3. Okay, and then I want to go ahead and solve this. We'll divide by 3. And we get our grand solution of 1. We did all that to get 1? Yes. Okay. All right. Here is the last example. Please go ahead and write this one down. All right, so I'm going to write these as the same base. Now, 27, I can't write these as base 9. So I'm going to have to rewrite both as base 3. So I have 3 to the power of 2. Jason, shh. Okay, and then I have 1 over 27. This is going to be 3 to the power of negative 3 to the power of 2x plus 3. Okay, so now I have the same base. Therefore, I can go ahead and put their exponents the same. So 2 times x minus 4 is equal to negative 3 times 2x plus 3. So I can go ahead, I can distribute. So we get 2x minus 8 on the right, negative 6x minus 9. And I'm going to combine like terms. So I'll move my x's together. So I'll add 6x, add 6x. This gives us 8x minus 8 is equal to negative 9. I'll go ahead, combine my numbers. I'll add 8 to each side. And we get 8x is equal to negative 1. Divide both sides by 8. And we get x is equal to negative 1/8. There you go. All right, and here is the last practice problem. Go ahead, pause the video, try this one, and I'll go over the solutions here in a second. Okay, the base that you're hunting for here is going to be base 4. This is 4 squared to the power of x. And on the right side, that is not base 4. What am I doing? Lying to you. This is base 2. Has to be base 2. So we have 2 to the 4th. And then 32 is 2 to the 5th power. Okay, so we'll go ahead. We now have the same base. So we'll set the exponents equal to each other. We get 4x is equal to 5 times x minus 2. And we'll solve the linear equation. 4x is equal to 5x minus 10. I'll go ahead, subtract 5x. And we get negative x is equal to negative 10. Divide by negative 1. Therefore, x is 10. That's your solution. All right. Hopefully in this video you learned how to apply the exponential property of equality to exponential equations. You make them the same base, so therefore their exponents have to be the same. Okay? Catch you in the next video. Peace out.